Good morning, or good afternoon, or good whatever time of day it is. I'm back. I got up today and I kind of just wanted to start coding. For the last for the last week or week and a half or so, my game engine's been kind of like my consuming project. It's been something that I can't seem to stop working on, which I suppose is good, but we'll uh, it'll just involve me doing a lot of work in the next couple of weeks. Where I left off yesterday was having really kind of polished out the INI file writing code. So using the INI writer API in my game engine, you can easily open up a file using the virtual file system, and then output stuff that formats into an INI format. Now, the trickiest part of this was an extension that I use for my INI files called dictionary values. That's what I'm calling them anyway. Is this bit where when you, instead of assigning just a regular value like a string or a number or whatever to your key, you assign a bunch of key value pairs that are comment separated in parentheses. So I've set up my engine to be able to write this stuff. This file was actually written by the code. So just to demonstrate real quick, in my initial game state, I'm setting up stuff for drawing a 3D little cube. And then here I am just demonstrating the INI file writer. If I press F5 to run it, and I guess I haven't built this morning since I added Doxygen comments, so it'll take a second to build. Or maybe 5 seconds. The tricky part about changing headers that are used in all kinds of translation units is that suddenly you need to rebuild all your translation units, so I'll give it just a moment to catch up. Maybe I'll pour myself a cup of coffee. It's still going, huh? Oh geez, that's a pretty long build time. I'm sure it's almost done. Any minute now. Cool. All right, yeah, so just a simple 3D cube spinning in the game window. I don't have any warnings, and if I go to check out the output folder, which I suppose I could do from here, go to data user. This is the file that was written by the code. So you see that the API is simple as just create the writer. You can either pass it the file name here, or you can do it separately in ini.iniout open. You can just open up a file. Then you can comment using the comment method. You can add a new line using the new line method. You can actually add multiple new lines. You can add 5 new lines just by pressing 5 in there. You can write a value out just by using .value. You can write a dictionary value out by using .dictionary. I might change the naming up later, but it just kind of works. All the value types that I support are coming out, cleanly. I did -1 for all these values, and so you can see the maximum value for all the unsigns because it wraps around to the top. And then if we take a look at the dictionary values that we just wrote out, it comes out cleanly as well. And this is actually a practical example of how I use use dictionary values right now, which is to place a whole bunch of mappings in a row, and each mapping has a name, the control, and then if it's a button, you got direction, and if it's an axis, you got scale. So yeah, it's working great. The only hiccup that I think is left is that it is actually possible to output an invalid string value. So if you go to This, for example, and do std string. If for some reason your string contains double quotes, I just did an escape character and a double quote, that breaks the double quotes that surround string values. And that's not necessarily, a big deal. If I go to rebuild now and we take a look at how the file writes now, we see that where is it? That all of a sudden we got the quote ending here, and we got this over here, which is not good. I'm just gonna leave that as a potential problem. And not bother fixing it, because to fix it, what you would need to do is you would need to, when you go to write the string out, you would need to pre-parse it, then insert an escape character, like a backslash for the escape character before the quote, so that way it's like the reader can tell that that quote is part of the string and not the end of the string. But I don't think I really care about that, because the odds of somebody actually wanting to put a string to an INI file that has double quotes contained within it, that's pretty low. That's not what an INI file is for. If you're writing out strings like that, you probably want to use a different format. So I'm just going to leave it be. So where we're at today is the INI file reader. This guy, INI reader. Now, INI reader has been around in my engine for a while. It was one of the earliest things I developed. I added it while I was working on my input system, because I wanted my input system to be able to read from the file. I'll bring up an example. Read from the file what each input is supposed to do. So this is just a simple input mapping that I am using right now. Currently, I'm not actually using these values. I'm just using exit. So basically, you define in an INI file, you have action mappings and axis mappings. Action mapping, I provide the name, what control it is, which direction the button needs to be pressed in order to do it. There's a whole system. But this is being read using INI file reader, and I need to improve the API considerably. So taking a quick look at INI reader, I'm going to take out all the oxygen comments for the moment, because I'm probably going to have to rewrite them all anyway. I used oxygen comments for my API stuff in the engine because I actually do generate HTML documentation from the source code. So it gets kind of wordy sometimes in the headers, but that's all right. It allows for nice IntelliSense and Xcode suggestions as well. Like when I'm looking for INI writer.value, it tells me exactly what it does. It writes a key value pair to the INI file, and yeah, makes things nice for the developer. If a little bit wordy in the header. And then I think I'll leave those comments for the moment. But you just, after reducing all the comments out, you can kind of see that it's not very straightforward. We have a constructor. The constructor will accept the file name that we're trying to open. It takes a Boolean that determines whether INI reader should crash the application if it can't open the file. When I was starting out with this system, I thought that would probably be useful, because if you're loading up something that is truly important, like like if you can't load the player's input scheme, then they can't control the game at all, right? That's no longer relevant. I've got a method planned for handling backups. So like if somebody deletes their INI file for their controls, that they can still play the game. And then the string section, this optional parameter on the end, you can specify a specific section of the INI file, and by section I mean this thing in the square brackets, that it will read from, and it will only read from that section and ignore the rest. You can also, if you end it with a dot, like input dot, then you will get only the things that begin with input dot, which I use in particular for the input system to determine when something is an input context and when it is just another INI section. So I think that's a system that I want to keep, the section mask. But you'll notice that I don't have a default constructor here. I also don't have the default constructor doesn't handle closing either. So those are some nice to haves that I have in my INI writer and my text file writer that I want to keep. Under the hood, there's a lot of other problems too. So like whenever we go to parse the file, it's got string allocations all over the place. I'm not sure that I'm gonna get to reworking the INI file parser while I'm on this stream. That's a pretty tedious task, and technically it works, so you know, if it ain't broke. But I do want to redo how we get values. In particular, I want to redo how we get dictionary values. As I use keys, I do want the ability to have multiple keys of the same name, which isn't a standard INI thing. That's an extension that some folks who use INI files implement, and I have. So whenever I do that, I want to be able to get all of the values associated with that key. So the way that I used to do that was I would say get, and then whatever type I need to read, like get bool, get int, get float, and then get multi-bool, get multi-int, get multi-float. So if it was just a single key, and we're expecting this to only be, or only to be one value associated with a key, then we just say, okay, we know it's a float, we'll get the float, we'll provide the name of the section, the name of the key, and the value that we want if it's not there in the file. And then multi-float would be returning a vector of floats. Default value doesn't really apply there because you can just return a empty vector. I do want conversion to be handled by the INI reader. I think I'll probably do something similar where it's just like get value. So similar to what I did for writer yesterday, where I just use overloads and you don't have to remember what type it is. And then I want to make sure that it supports all the standard types that we support. And I got all these basic types from the overloads for OStream. So like on CPP reference, I looked up all the different overloads that are offered for OStream for the basic types, and I've implemented those, and then a couple of others. For example, I've overloaded the ability to write strings, characters, and car pointers, which are not they're not handled by operator overloads within OStream itself. They're actually operated by like friend operators or something. I'm a little vague on that. Or overloads associated with those libraries, with the string library and the C-string library. But I want all of those types to be directly convertible out of here. So what I'll do is I'll do probably value and multi-value. So I can do a similar thing where it'll read just the value by itself, or it'll read the value or all the values associated with the key. And then dictionaries, when I first approached dictionaries, when I first wrote this, I didn't really have an easy way to store data. So the way that this currently loads internally is that there's a an unordered map, a hash map basically, associating the name of the section with another map, which associated the name of the value with a vector of strings. And that's kind of a mess to interpret, but the vector of strings was the list of all strings associated with a key. So for example, with access mapping here, this was saved as a string, this was saved as a string, this was saved as a string, all associated with access mapping, or to be more precise, with the hash name of access mapping. So it's actually an integer associated with access mapping. And then all of that was sorted away underneath underneath yet another hash name, and that was the hash name of the section. So that would be this whole thing. Yeah, it gets kind of complicated how the data is stored. I think I kind of have to do something like that, because until the dev chooses how to interpret the value, we don't have a definitive way to know what the value is. So if we look at the output file from the previous example, each one of these is a different type that we can write out. All of the integers are just written as integers. We don't know what kind of integer we want to cast to or to interpret as. Floats don't even look like floats until you interpret them as floats, because you write out a float that doesn't have a decimal behind it. It doesn't do the 0.0 or f or whatever behind it, and that's okay as far as I'm concerned. That's what you would expect when you go to write out. Let me unbreak that from the earlier demonstration. That's what you'd expect when you write out to the console, when you use stdcout, so on and so forth. The only two things that I've changed from outputting to the console would be booleans now print as true or false, because I think that's useful in human readable files like this. And strings come out as in quotes. And cars use single quotes instead of double quotes. And those are the only things that we change. So when we go to read such a file, we don't know what format that it will be used in. So we kind of have to read them as strings until the dev chooses to cast them as something. So yeah, when you go to read a file, I suppose that we'll have to kind of like associate it with keys and names and stuff. Because if we don't create a structure by which we look up the data by by name, by key, then we're stuck reading the file line by line. And that's exactly what I don't want the developer to have to do when they're reading one of their INI files. So the broad strokes of reading the file in and then storing the associated strings, I think that's something I want to keep, and that's fortunate because I don't want to redo the parser today, though I'm eventually going to have to. So for now, what I'll do is I'll just get this API redone. When we're dealing with dictionaries, I used to have to return a map where the right-hand side was the string. I now have a better solution. So when you go to write dictionary values out, I have a type def created for the type that is the right-hand side, an INI value t. What this will do is it's a variant containing all of the types that we support in an INI value. What we could do, actually now I'm having to think a little bit harder about this. What we could do is we could find a way to return the key value pairs as hash name and as the INI what's it called? INI value type, like that. But the problem is is that we would need to specify when we go to get the dictionary what all of the values are. Going back to the way I had it before, I actually had to have all of these helper functions up here. Just to allow devs to quickly convert the string to whatever value type they need after the fact. And I really hate this. This is not very elegant at all. The idea that you'd have to you use the helper class to get the string, and then you have to convert it yourself, even if I provide you help. So I guess we need to provide a way, and we're getting into API design territory now. We need to provide a way for devs to tell the INI reader which types we are expecting. So what we could do is provide another parameter to this. So we've got the section and the key. So the key being not any of the subkeys, but the name of the line that contains the dictionary. And then, maybe an initializer list. And the initializer list would be a list of types, I suppose. Man, you can see where this gets muddy. This is not an easy thing to make a simple API for. I want to shy away from doing things like OStream operators for INIs specifically, because I think the power is in providing the name of what you want and then getting it. And there's a couple of other reasons too, related to how we'll do INI file merging, which we'll deal with later. But an INI, an initializer list, or a map, or a vector of which types are associated with which keys. Now, for that to work, we could certainly provide provide an STD pair, so a list of pairs of keys and then types. So the key would just be the hash name of the key, which is something that the dev will always have. Then the second thing would be a data point representing the type. And that's where it gets trickier, because the type def can't be used as a data point. It is a type, not a piece of data. So what we would have to do would be something like a union class type. It would be like INI value type or something like that. And yeah, one of my goals for the engine is to reduce the complexity to the point where somebody can just kind of come in and understand what's going on, even if they're just learning how game engines work. This is a situation where, in order to have all the features I need, I think I got to go a little bit more complicated, and that means a slightly more complicated API here. So you'd be providing a list of sections, keys. Or so you're providing the section name that you're looking up, the key that you're looking up, and providing the types for each key you're looking up. And actually, this is an interesting opportunity as well, because the way that I had it before, you would always get the list of every single key located in the parentheses. But this would provide an opportunity for you to specify specifically the keys you are looking for. So it's only returning in this list back the subkeys that you care about. So if somebody was to insert a whole bunch of crap in here, like whatever, obviously it had to be formatted in such a way that that it doesn't break the file. But if somebody has, you know, keys in here that you don't actually care about, you just don't specify it in the get dictionary list, and it just will skip that, return the ones that you specified. So I think I'm kind of liking the direction that this is going. So let's get the ini value type enum going, and I'll probably rename it later. So these are all the types that we support. I guess I'll need to rename a little bit for each of these. So we'll have, can I just do the type name? I don't think I can, because there's a parsing conflict with the keyword. So what I could do is I could follow each of these with like an _t, or I'm not sure. What did I do for graphics? Because I have in my graphics API, I have something called shader data type, which lets you specify the type of data that you're providing to a uniform buffer or a vertex attribute format. We just got simple names with caps, so int, uint. Yeah, I think I'll just go along those. I'll just use short int, u short. That's not a dis, that's a type. U short int, and then int, uint, and I guess long, ulong, long, u long. Yeah, I guess we'll just do capitalization for these, and then just do a capital U for the unsigned. They just have to be different enough that they're not confused with the actual type. Float, double, L double, bool. Technically, we support pointer types. I don't understand why. At the outset, I can't anticipate a reason why somebody would want to serialize a pointer, but in case they wanted to, they're welcome to. And if they're using a templated function that would have returned a pointer but doesn't, then they might have a null pointer type template overload. So it would actually be technically not a pointer type. So a null pointer type is, that's why the overload is provided, I think, in the OStream API, though I'm not an expert. So I guess pointer, then null pointer, and then we got string, character, and then C string. And that should cover our bases. I should do a none for the first value, none equals 0, so that we have a null version of this type. If only for error catching. But yeah, short int, u short int. I suppose I should round these out by saying long int. Or should I? Is that better? Is that actually better? Short int, u short int, and u int. That's not better. And I'll get rid of the int on the end, so it'll just be short, u short, int, yeah. Okay, yeah. And now that I've got this type, I can provide it into the template of the pair here. ini value type. ini value type. And I'll probably need to rename this when we're done, but right now I'm just hacking things together. And then subkeys. There we go. Now this has gotten kind of wordy. Let me get rid of that formatting space I had used previously. And let me change this from an unordered map to a map. I think originally I was just doing unordered map everywhere because it actually hashes the keys and theoretically would make a faster lookup. I think I prefer map now in the general case because it's technically a faster lookup in some tests that I've seen. And also because hash name is just an integer anyway. I'm taking care of the hashing. So when you go to push something into the map, it doesn't have to hash the value. It just uses the comparison operation, which is just compare one integer against another, and that's pretty fast. All right. So we've got a map, get dictionary, takes the section, the key, and then a pair of, or a list of pairs. And I'll probably provide an overload where instead of the initializer list, it is an std map of these things, and an std unordered map of these things, which is this is how I had done it with the reader yesterday. Unordered map. There we go. Unordered map, hash name, INI value. The last little detail I am wondering about is the section. I don't know if it's valuable to provide the section that you're looking in each time. Because what you could do, for example, is because you're already filtering to specific section or sections, what you could do is you could just have the INI reader make that a part of its state. So when you go to open up an INI reader, you call something like reader dot open section or something like that, and then suddenly all the keys you're looking up are part of that section. I kind of like that on the one hand. Because it'll reduce the complexity of calls like get dictionary, and it'll make the get value calls simple as dirt to not have to provide the thing. You're just providing the key you want. But on the other hand, that's just another thing that the dev has to remember. They'd have to remember to call the section header, and then remember, don't forget to open up another section before they start reading in another place. And that might be, just like not too much responsibility to put on the dev, but because we're going to be reading all of the INI file, we're parsing the whole thing and sticking what we care about into memory in the first place. I think, yeah, after taking this time to review this, I think I'm going to leave it in there. Because what'll happen when you open up an INI file is that first it'll parse through the whole thing, and then depending on which section filters you've provided in the constructor or the open method, it will include only the keys in that header, or beneath that section header. So only the sections that we care about are in the map in the first place. But if we're doing multiple at a time, so for example, in my input system, I will read any section that starts with input dot to get every context. then it might be best if you had to specifically tell which section you're reading from. It's occurred to me just now that I'm not sure, I don't remember how the input system gets the names of every section in the input section. So let me quickly look that up. That was underneath input.cpp, I believe. My input system. And it would be underneath load context file. So load context file opens up the INI, providing the input dot section filter. So there's a sections method that returns the vector of hash names of the sections. Got it. So there's a lookup function for getting each section that's in the. Okay. And then from there, with the context name. Yeah. So from there, it actually works. It works by the fact that the filter that you provide is actually stripped from each section when you read it, I believe. Yeah. So that's fine. Yeah, so I think I'm going to leave that. So the get dictionary functions, I want to look like this. So you have a variety of ways to get the to provide the type that you want to store in. The return value needs to be INI value t, which is the type def I provided above. For all the types that are a variant of all the types that I support. And then I'll need to have the get function actually cast that to the correct value or write it as the correct value from the string that's in the INI file. And now I need a version of each of these that returns if we have multiple keys with dictionaries that have the same name. So get multi-key is used for action and access mappings constantly because all of them are dictionary values, but they are all associated with the same key. So we would need a version of this that gets you back a vector of them. Or do I? Because I could just do the vector for the regular get dictionary call, and then if there's only one dictionary associated with the key, then it just would be a vector of 1. That's totally doable. There's never enough coffee. So this would be like get dictionaries, and then you provide the name of the key, and it'll provide you a list of. That seems like a lot, though, doesn't it? Like, for somebody looking at the API to say that, okay, it returns a map, or a vector of map of hash name INI value t. It is simpler to look at it and say, okay, it returns a map of hash name and value t. That's just easier to wrap your mind around from the get-go. I think I'm going to keep both then. I'll just do a version of this that's get multi-dictionary. And as I'm testing the API, if I change my mind, I'll just consolidate it into a single call. means making a version of both of these where we're returning an std vector of maps. And do I want to multi-dictionary? Do I want to pass by data? I suppose I would have to, because if I'm constructing a map that only contains the values I care about, and the fact that I'm converting them before they get to the map. Yeah, that has to be by value. I'll just have to hope that the compiler is smart enough to construct the vector and the map in place. Well, in the case of the vector, technically that memory is always on the heap. In the case of std map, hopefully it'll be smart enough to put that stuff in place. So yeah, that's that. Let's redo the API for getting values now. This was kind of a crude way to handle it before. So what I'm going to do is I'm just going to do just do a bunch of overloads of get value. Oh, but okay, yeah. Now I'm realizing that I can't actually do it that way. What I was thinking was I would do a version of get value that would just differ by return type, but that's not how overloads work. You can only have them differ by their parameters. You can't have them differ by their return type. So I can't just call all of these get value. What I could do that I couldn't do before was return the ini value t, the variant type, which would reduce get value to one function. The downside there being that the dev would have to call their own std get on the value in order to get the correct value type out, which, I mean, not a small ask. It's actually literally what I'm having them do for the data that gets returned by get dictionary. Does std variant automatically cast to its types? I'm pretty new to std variant, so I'm having to look up every little thing. But it just occurred to me that if somebody was writing code that would accept the return result, then maybe that's a problem that would take care of itself. So for example, if I did an std variant that does bool, float, and int, and then I assign it a bool. Now its type is bool. Would it be possible for me to just say bool value equals test variant? No. So there's not it doesn't automatically give you a conversion function. Okay. Yeah, I was thinking that maybe the devs wouldn't have to use std get on the variant, but instead they will have to do std get bool and pass it this. I believe that's how that works. And then it will convert, unless it's not a bool, in which case it'll throw an exception. But yeah. Yeah. So thinking about the design of the API again, what getting a bool value out of a key might look like if I do the variant is it would be I would create a file ini reader. It would be like ini in profess it, some file .ini. There's more calls to that, but I'm not going to bother with those details right now. Then they would have to call ini in dot get value, and then the name of the section, the name of the key, and then that would be it, right? Section key, which, yeah, that's a little complicated. There's not really a way around doing that for dictionaries, but yeah, you will need to do. So in the case of get value, I think I will go ahead and do this again, just because it's that much easier to look up a bool without having to wrap it in a templated. Yeah. Okay. So yeah, let's head back to the file.h then. I guess I'll need to stick with the naming convention before. I didn't really like it, to be honest. Get bool, get multi-bool, but it seems like it's probably the best way to handle this. In get dictionary, there's not really a way around getting a vector of maps. Yeah. Okay. Yeah, so I think that's the API then. We would actually just leave this. However, I would need to get more types. Does it matter if I get more types? Like, if I don't provide get long or get long, then they won't be able to read a 64-bit wide value. How do I even do that? Get int converted. Yeah, the conversion function was ini string to int. I do some checks to make sure that it's fine. Then I ultimately use s2i. Which doesn't support. I would actually, if I needed to get a long integer out, I would actually need to do s2ll for long. The thing that I'm getting stuck on now is that if I actually wanted to read every supported type that we can write out, then I would actually have 16 overloads. Actually, I would have 32 overloads, because there'd be the overloads for the values themselves, and then the overloads for the multis. Yeah. I think for the sake of being robust, we'll need to go ahead and make all of those overloads. Man, okay. That isn't great, in my opinion, but that's just what kind of project this is. This is the sort of thing that you don't want to think about while you're developing, but if you need to read a specific kind of value, then you don't want to have to come back into here, modify the engine code to provide those extra types. So you want to get everything you might need taken care of ahead of time. Yeah, so back to here. I'm copying and pasting all the types so that I can refer to the list. Yeah, so we've got, I'll do this in the same ordering as the other. So bool and multi-bool come down here. Actually, they will be above string and multi-string. Float and multi-float is above bool, and int and multi-int is above that. I don't think that there's a S2S function anyway for string to short. Let's take a look. Yeah, you can do S2I, S2L, and S2LL. There's very little case for having it explicitly converted to a short before it gets to your function. So I'll go ahead and skip get short. I will, though, need get long, and so on. And for that matter, I will need to provide unsigned int as well. Just because if somebody needs it to come out as an int, but they need it to be in, you know, the upper range, only half of these values are available in int because of the fact that it needs to include negative numbers if it's a regular int. So yeah, I'll do get int, get multi-int, and then I'll do get uint, and then get multi-uint. Man, this is wordy. That's, I don't know, maybe I'll have an epiphany in the shower for doing this a cleaner, better way. So we got the get int, now we need get long. Let me do it here. Long int with all caps, and just replace it with long. Get long is just a funny, funny function name. And then get long, which is a slightly funnier function name. But long in all caps we'll replace with long. Cool. So now we've got get int, get uint. So I've got all the int types taken care of, with the exception of short, and that's because who cares about short. Float double, long double. So we got float already. Just need to do double and long double. Okay, and we've already got bool and multi-bool. Good. We don't have pointer types, which, you know, you could argue so what, but I'd argue that it might matter someday, so it matters now. So this would be, I guess it would be const void pointer, but because it's not actually used as an address yet. It doesn't matter if we make edits to it. I want to leave that to the dev, so I'll just do void pointer for the type, and we'll say get pointer. And I'll need to go through these parameters as well on all these other functions to make sure that they're correct. Get pointer, and then null pointer. So null pointer type. That's no, that's not valuable. When you're serializing, you may need to have the null pointer type overload, just in case you're using a templated. You're trying to serialize a member of a templated function that the template happens to specify null pointer in the case when it's not actually a valid pointer. But when you're deserializing, there's no value in getting a null pointer type. So what we'll just do is that in this guy, we will, when we actually go to serialize or deserialize the pointer, we will simply use null pointer, the string, to mean null pointer, the type. And we will just return null pointer if the term null pointer actually appears, because this is what actually serializes if you do std cout and you pass it a null pointer type, because it says null pointer. So yeah, what we'll do is we'll just handle null pointers in there. Then that leaves the string, character, and C-string, which we've already got string. We don't have character, and we don't have C-string. Well, C-string is literally the same code. It's just that it's not passed out as a constant car pointer. I don't think I want to pass out a C-string either. It is equivalent to an std string, and an std string comes with a nice handle on it. And all my APIs that accept strings use std string anyway. But you know what? There might be some dev that wants to provide like a buffer or something and want to do it the C way. So for the moment, I will go ahead and add a version of this, which is void or bool. It'll be get C string. Though the name suggests that it's the actual type. No, I'm not doing it. There's no point. But we do need to get the character, though, because we need to have a version that interprets the single quote C as a character, or if it was just a letter C by itself, like if we want to make sure that it's not interpreted as a string but as a character, so we'll leave that overload. Get string, get string, and then it would be car, get car. And then get multi-car. Which, you know, you could get multi-car kind of sounds like you're getting a string. And admittedly, the idea of having a whole bunch of letters being passed to the same. Oh, it's I was trying to use Control D to duplicate. But the idea of like having like something like that, where somebody's like got a key name with a bunch of different characters in it, seems a little silly. But you never know. I'll leave it. I'll do a get multi-car. And that would be an std vector of cars, which is a string, right? But whatever. It's just a little bit more clear that this is that the characters are not necessarily associated with each other in a string. Yeah, okay. So it's a little bit wordy, but I think this covers all my bases. I almost wish I could do this as a template type, where I could just do get value, and then have the return type t, and then it would be like get value where you pass the t. But the problem with that is that it would require that I be when you're only doing a specific list of types instead of any type that meets a certain criteria, then you're just better off doing overloads, because you never know what edge case you're forgetting. I'm not basing this off of any criteria other than the types of values that you're allowed to have in an INI. And I have a specific list of types that are allowed. So I guess we'll just have to stick with the overloads. When you're working with the INI reader, that would look something like ININ dot, and then you've got all these getters in the list, which, the whole point of the INI reader is to get things, so that's not really a problem, I guess. But it does feel like get int to have all these additional options might be a little overwhelming. But I'll get used to it. I'll forgive myself. Okay. And an additional perk is that this won't break the API totally for input, which input uses the INI reader extensively. Yeah, so let's get back to here. We need the sections. I don't know if we need get last error. I don't think that actually applies anymore. No, it doesn't. And let's get the constructors sorted out. So I want to have a default constructor, and I want to have a destructor as well. And the destructor we'll simply call close. And the load function I want to rename. Where did it go? Oh, here's the load function. I actually want to redo the load function and make that open and pass in some things. Let's talk about what we need when we open up an INI file. So I'll just start it with here, void open. How did I do this in the text file reader? I did open returns an error code, I believe. I guess I could do the same. Did I do that for INI writer? I did not. And I didn't even handle the error code in open for INI writer. So yeah, that might need to change. The idea is that if I open up an INI file, the code should be able to decide what to do with the open status. So yeah, that should return an error code. And essentially what that'll do is it'll forward the error code from the open operation of the text file reader, which is under the hood. But let's talk about what we need for the open to work. The first thing we need is the file name, or file path, I guess. I'll just call it path. So that's the path to the file that we are reading. We also need a second path, and this is where the API differs from what we had before. We need to know which file to load if the file that the working copy of the INI that we're looking for doesn't exist. So the plan is this. The backup path will be the clean default copy of the INI file. The idea is that when you install the game, it'll install the basic clean defaults INI files with the content. So in Windows, within the program files folder, and on Mac, within the app bundle. And then the first time you launch the game, it will make a copy of it in your app data folder. So in Windows, it's actually called app data in your user folder, or roaming app data. And in Mac, that's a folder somewhere in your library folder. And then that's the copy that you read and write to while you're running the game. So when you tweak a preference, that preference isn't saved to the the golden copy in your program files folder. That's saved to the copy that's in your user app data folder. So that way it only affects you, and you can always revert to the defaults in the folder. And so if the user was like an elite hacker or something like that, people who go into their Skyrim preferences.ini and they go and start tweaking things, if they screw something up, they can just delete the INI file. Then the game regenerates it from the clean copy located in the program data. Though I think Skyrim might have been a bad example, because I think they actually put it in a different location than their program files. I'm not sure. I can't really remember. But that's the idea. So whenever we go to open up an INI file, we are providing both paths. We are providing the path of the copy that we're going to be working with, and then the copy to load from if it doesn't exist. And actually, there might be an additional way we'll use the backup path, but I'm not going to get into that for the moment. I'm no longer going to provide are errors fatal, because with this setup, you should always have a backup plan if you can't open the file at path. It will just read from the golden copy. What I'll probably do is I'll probably throw an error, well, not throw an exception or anything like that, but actually generate an error for the dev if they are in a situation where they call path, they need to reference backup path, and backup path doesn't actually have the file there. So I think that's how I'll handle that. So no, we don't need the are errors fatal. We do need the section filter though. So that's going to be another string. And we provide a default of empty quotes, which just means that if you only call the two paths, then it'll read every single section header in the file. And I do want to point out that the section above the first header is actually a valid section. It's just the section that doesn't have a section name. Sometimes it's called the global section, and I think that's what I'm going to continue to call it. Okay, and then we're going to need all of these parameters in the overridden constructor, and we just basically pass them through to open. Path, backup path. Nope, that's not backup path. Backup path, and then section filter. Cool. Is open undefined? Open is defined right here. Oh, yeah. Close is undefined. Did I? Oh, you know what? I don't actually need close. This is actually probably why I didn't have it before. In the case of text file reader, I needed a close because we are leaving the file handle open while we are streaming in data from it. That's actually not the case with INI reader. All it's doing is it's scanning the entire file and building an internal structure with which to retrieve the data that you need. So yeah, we don't actually need to override the destructor, and we don't need a close method. The file will actually just be closed as soon as we have parsed it in here. And there's a long-term goal I'm trying to keep in mind while I develop this, and that is the ability to easily merge data from one file to another. I think not handling this like a stream, I think that aligns with that goal. So eventually what we'll do is in the file writer, I want to like maybe specify like a Boolean parameter for open that tells us whether we want to completely overwrite the file, the destination file, or if we just want to merge data with it. And if we want to merge data with it, then what we can do is we can track when we go to write the data to the temp file, because this writes safely to a file with a random file name in the temp folder. When we write that data, we track which sections we are dealing with, and then it will open the destination file using a reader by actually instantiating an INI reader. Get all of the data from all of the other sections that we haven't written to, and then we can serialize that back out to the file alongside the other. So I think this lines up with that goal nicely. Basically, the way that would work would be that in here, every time we call section, we push the section name to a list or a set or something. And so we track which sections we would be overriding or replacing. And then when we call the INI reader, so when we go to close down the file with INI writer, the INI reader could then open up an INI reader, passing in the section filter, passing in section filters for just the sections that we didn't overwrite. And then it would simply write everything from the stuff that was serialized in the temp file to stuff that was already in the original file. But now that I've said that all out loud, I'm realizing the problem. Oh hey, Amex Conrail. I'm not really paying attention to the chat very much because there's basically nobody in here. Sorry, you might have been in there for a while. How's it going? If I do. I think, yeah, now that I've worked out the logic in my head for how merging might work, I'm realizing now that this might not be sufficient to just have a single section filter. I may want a list of them to be able to specify I care about this section, and this section, even if they're not part of the same section group. So that means like I want Windows settings and input.context, but not anything else that has input dot in front of it. Yeah, I think that's what I wanted. So let me go ahead and change this up a little bit just to be an STD. Probably a vector. Can I do that with const string references? Because a reference is technically not a pointer. I guess I can. I guess I can push back those. We wouldn't need a default value anymore. Because we can just pass back, we can just default to a vector with nothing in it. So yeah, let me do that as a default value. So that way you can just call these two, and then if you don't, it'll have an empty vector. Yeah, sorry if I totally missed you, Mixconrail. I'm not really doing this as a show. I'm just kind of like working out loud on stream because it kind of helps me work a little bit better. I'm not really paying too much attention to people popping in and out, which is, yeah, maybe that's rude of me. We need to replace the type now for this guy. Cool. And I guess we could pass it in as const as well. Seems like a lot of const references. I just don't want to be passing in this stuff by value. And we actually will want the default value here for open as well, because even though I primarily will be calling the constructor to open up a file, it's totally doable to have an INI reader just like stick around and then you open up multiple files. So you might just leave the file open, call open when you need to open up another INI, and then that'll flush the data representation we read from the original file, and then just do it again for the new file. We do need sections, which is going to be a vector of hash names. Hash names are, if I hadn't covered this, they're just a way for me to rapidly hash a string, and even to hash them at compile time. So in the shipping version of the game, you're not going to be doing an if check with, or a comparison between two strings. You're going to be comparing just the hashes, and that's way faster. Okay, yeah, I think that's everything I need in the API side. So I guess now it comes down to reworking the implementation of it. So the first thing to do on that front is to go into ini.cpp. Originally, I was going to have all the ini reader writer stuff in the same file, but most of this is the ini parser, which can be quite lengthy. So I actually did the INI writer code in its own file. So the logic for writing out dictionary values and stuff is its own file. So I think I'm going to start by renaming this guy to ini-reader.cpp. And then we will start overriding everything. I've removed the need, going back to the header, I've removed the need now for these functions and for that to-do message. because now instead of returning when we're getting a dictionary value, instead of returning the strings, I am actually returning the pre-converted value as determined by the type that I provide the subkeys parameter. So there's no more need to convert the string outside of the scope of the file system. So those declarations are gone. Let's go back to, let's pin these so I don't lose track of them. And in here, I'm going to leave the stuff in here commented, just in case I need to refer to how I did those conversions, which I doubtlessly will. I think I may actually use those in the parser, but I'll come back to that later. And let's make sure that we've got all of the API methods, the developer-facing stuff available. I think this needs to be equals default to the default constructor. I'm always referring back to my other code to make sure that I'm doing this correctly. Yeah, I did. Yeah, so I guess in the other ones I didn't do equals default. I just did an empty constructor, and that's probably fine, actually. Yeah, I'll just do the default values inside the private section itself. We'll just assign those directly. Just to keep in parity with those others, I'll do an empty constructor here. And yeah, so first of all, load was the name of the function before. Now it's open. So let's go to load and work on that. So load is now open. We don't do that anymore. We still call it section filter. We need to do const std string reference backup path. And then declaration is incompatible. Oh, that's because this is this needs to be a const std vector of string references. I might rethink this later, but for the moment, I'm just gonna get everything working and then revise my code to make it clean and pretty. So now we've got an open function. We are handling the INI reload mechanism now. This note I have here for handling a constant section, I'm actually going to remove that now because since I wrote this, I started a Trello board, keeping track of all the things I need to do. And I already have that in a stretch goal item, is to add a constant section. The idea is that a constant section in an INI file is not very common, but the idea is that you would have like a section header that's dedicated for constants like this. And then whatever you put in here for key and value, that key becomes a constant that you can use as a value later on. So you could do, for example, jump or move key y, and set that equal to, KB, I don't know, KBA or something like that, or a dictionary or something like that. And the idea is that you can use A's to the left. Let's just make W. The idea is that you could use this instead of KBY everywhere. That's the idea of a constants section anyway. It's kind of there's not a huge amount of use cases for it I can think of, but if you wind up having to define a lot of keys based on the value of another key, it might be helpful. But yeah, it's definitely a low priority for the moment, so I'm not even gonna bother with that for now. So let's look at how we handled the open before. What's going on here? Declaration is incompatible with Is the declaration incompatible? I thought we got everything. Go back to the open path, backup path, path, backup path, and the vector of strings. Oh, I didn't make it a reference. All right. So the first thing that we did was we went to determine whether the filter is a group. So that means two things. First, is there a filter? And does it end with a dot? Now, this logic doesn't actually apply anymore because we have not one section filter, but a vector of them. So I'm going to comment that out for the moment. We still do need to, when we go to use the section filter, we do need to identify whether it's a group or if it's just a section name, which we would use for beta. What we should do up front, though, is what the last half of this does, and that is to confirm that all of the section filters have valid names. We have, when we go to write using the INI writer, all these checks are done at the time that we serialize. But the whole point of an INI file is that people can go in and type in their own values. So we need to handle the case where somebody screws up the name. Now that said, this is kind of error checking on the code side because the developer calls open, not the gamer. So if the developer goes to invoke open, is there a chance that they might use section filters that are loaded from data, from like a data file? That's tough to say. They might. If you were working on a game that had like a creative aspect to it, I mean, not that this is even a realistic possibility for this engine, but if somebody wanted to do a game in the style of what's it called, Little Big Planet on PlayStation, where they do you can make your own games or make your own, do a kind of a crazy sandbox thing. You might want to be able to name INI sections after data that the user types in. So if you were making such a game, you could argue that the developer should be careful to format the text that they enter in a way that's compatible with INI section names. So meaning that it has to contain only alphanumeric and the dot, the hyphen, and the underscore. But if they forget, I don't want this to break their INI files, so I need to check them all here. So it's possible that this might be past text in some hypothetical situation that was entered by a gamer at some point. You never know. In which case we would need to do a loop through it. So let's do for const std string reference filter in section filters, plural. Just occurred to me that I need to make that plural. In section filters, now we've got we're going through every string inside of here. we need to confirm that it is good. Now, I've written a helper function for this already in ini writer, and so I think we can use it here. It is key string valid, and I'm going to go ahead and just duplicate it for this file. I would rather... Well, you know what? These are both platform-independent files. I'm going to make this a member of the file header, or make the file class. And what that'll allow me to do is use this in both files and only compile the method once. So we got bool is keystring valid. And it's a really simple function, really. It just, all it does is it loops through the entire string, confirms that the character, that every single character is either a number, letter, or one of the 3 special characters we like, and then return true. So let me go ahead and get this guy in file. File. Where do I want to put it, though? I suppose it would be private. You know, this actually has such wide-reaching applications that I might want to use it outside of file, too. Is that realistic? Do I really want that? Yeah, let me, I'm going to cut this whole thing out and move it to file.cpp. I'm going to put that in here underneath, I guess underneath backslashes to slashes, which is a similar helper function. Put it in the file namespace, and I'm going to call it is alphanumeric, which isn't exactly accurate because we're also checking for these 3 characters which aren't alphanumeric, but that's, you know, whatever. This is probably going to be useful in any situation where we want to make a file name or a data point that's, or a serializable data point that doesn't have special characters. So we will do file is alphanumeric. We'll go to the file header. Underneath backslashes and slashes, I'll put the function in here. It's a static function because that's how I do my systems for some reason. And now we've got is alphanumeric as a helper function throughout the file system, which is good. It's probably not chef's kiss good, but it's pretty good. It's still better than before. Let me fix the references in here now that I've removed the function from the scope. So is key string valid is no longer is key string valid. It is now is alphanumeric. And the scope should be right for all of these, so I can now replace with is alphanumeric everything in the current document. 24 occurrences replaced. Now let's watch those red lines disappear. Sure, it's defined. I defined it here. Visual Studio has been sometimes taking a little while to clear warnings and errors out of IntelliSense, so I'll give it a minute. Yes, like this one's not reporting an error. I'll come back and see how it's doing later. But yeah, anyway, so we just need to check if section filter filter is the string that we're working on. We'll call it is alpha numeric on filter. And so now we know whether the warning's still there. Come on, Visual Studio. I know that you know that this is okay. you're in the file system. Maybe I have to save the header. Maybe that was the problem. Whatever, I'll come back to it. So if it is alphanumeric, yeah, then we know it's okay. If it's not, then we need to present a warning, I guess. Maybe I should be doing this check later on, because if the section filter isn't alphanumeric, then I want to skip it. Let's get rid of the const here. No, let's not. What I'll do is I will make my own vector of string references. I'll make a local one here. And for every filter that is alphanumeric, I will push a copy on filters dot pushback. I will push back the filter. And then when we are working with the filters later, we will use the valid filters. Filters here meaning either just the section names or a section name followed by a dot, indicating that it's it represents a collection of sections. So yeah, and then we'll hold off on determining whether it's a group until the point we go to use it. All right, now here we are storing the path of the working file. I don't think that's important in this case. It might be though. The way that I had done the parser previously was that I would use a text file reader to read the contents of the file and then parse that. But because we are parsing through the entire file, I think I'm going to change that. I think I'm going to, instead of using text file reader, I think I'll just grab the entire file, dump it into a string, and then read that string. Because we're doing a whole file analysis anyway. And INI files are not likely to be very long. I don't know, I'm on the fence about that. For now, I'll leave it as the text file reader and not get too deep into the parsing stuff. And then the path will automatically close at the end of this function anyway, because the text file reader is not a member, it's just a stack allocated object. And when it gets destroyed, or when close is called upon it, it will automatically close the handle to the temp location. So it'll automatically close the handle to the open file, and we don't need to reference the path after that. So what did I even use npath for later? Anyways, did I even need to use it as a... I guess the reason why I have it is just so that I can provide the path in warning messages when you try to read a value that's not compatible with a type. So I guess I'll keep it. What I think I'll do though is I will mark it as debug only or debug and dev only. That doesn't need a name. So if ndef ep config dist. So ndef. So basically, the preprocessor will only include this when we are in debug or dev builds. Distribution builds don't have a need for it because they don't need to print the message. Or do they? Do they need to print the message? Well, let's think about like the Little Big Planet scenario, where somebody's got data that should represent part of their scene or part of their level or whatever. Yeah, you know what? I will keep it in distribution builds because it is possible that you might run into a situation where the data file was modified by the user to include a value that is not compatible with the type that it needs to be read with. And they might want to see the error message, maybe like as a modal pop-up or, well, modal pop-up would be pretty game-breaking, but you know what I mean. I'm going to need to keep that data point. So we'll keep the path. We will open up the path in here. However, I am going to take an extra step for the path that we store. I will convert it into a native path before I store it. So we have a function called vpath to native path in the file system. It takes a path that is formatted in the enterprise virtual file system and actually tells you where that path is on the computer you're running the game on. So if you're using C/ to get to your content, it will actually tell you where the program files folder is and so on. I'm doing that extra step so that way, if and when we print an error message, it'll tell us exactly where on the computer the file is, which is more useful for a gamer who doesn't know about the virtual file drive system. So that's how that's going to work. But for the text file reader, it actually takes the virtual path, so we'll just leave that as it is. We'll get the error code from it and store it. And that's important for error reporting, for if the INI reader has an issue opening the file, the game might need to know it. Yep. Another way we could do this is by creating that and then setting error code equals to INI open and then drawing path. That might be a little cleaner, so I'll do that. Cool. And if the error code equals a success, then we do all the parsing. If the error code does not equal success, what do we do? Previously, what I did is I crashed the game if I provided our errors fatal into the parameter. They no longer can be. What we'll do instead is we will open the backup path and try and use it instead. And if the backup path doesn't work, then we do have a problem. So just to be sure, I haven't taken a look at this code since I replaced the guts of file reader to use ifstream. I want to double check that trying to open doesn't create the file. Opens the stream. If the stream is already associated with a file, calling this function fails. I'm like 99% sure that it can fail to open if the file doesn't exist, but I'm actually not 100% sure. Maybe ppreference.com will give me a little bit more info. Not there. Let's go to its member function open. Let's take a look at the page for the error messages. I forget exactly. There's a page on here somewhere that tells us exactly what all of the errors might mean. Or what might trigger it. Here we go, IO state. And if we were doing open from a stream, constructors of fstream, ifstream, blah, 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 blah. The fail bit, if the file cannot be opened, if the file cannot be opened, cannot be closed. It doesn't clarify whether we'd expect it to open or fail to open if it doesn't exist. My impression is that when you're using an IF stream, it's supposed to fail to open if the file doesn't exist. And I can catch that with enoent for the error no. I'm going to presume that that works for the moment, and I shall have to test it later. But the error code should be does not exist if the file hasn't been created yet. So at this point, I can actually completely ditch the else statement and do a new one. Else if m error code equals error code does not exist, then we can handle that. But now that I'm thinking about it, the response will be to try and repeat the stuff in the above if. So let's take that out of there. And actually, before we open up, the parser, we will do a separate if check for whether it does not exist. So if the file didn't open because it doesn't exist, we're actually okay with that. We just want to open up the backup path and use that. Well, actually, we don't even want to open up the backup path. We want to copy it to the actual path and then try and open it from there. And this is where it gets a little bit hazy, because whenever I deal with this sort of operation, whenever I've dealt with this sort of operation on INI writer, I would actually pass that off to be really? Is it still giving me grief? Why would that be? Alphanumeric is definitely alpha. Oh, I capitalized N in numeric. Fuck me. God damn it. Why would I make that kind of mistake? That's just how I am, I guess. Okay. All right, that should be all linking properly Anyway, previously I would use Windows API calls to handle moving and copying files. Let's see if STD file system has got something that I can use. It's not quite as critical that I use Windows API for this operation because I am copying the file, not moving it. But we are in C++ 17, and I've started to use the file system library for a handful of other things. Let's see what we've got. There is a copy option. There's a copy method of the file system. The STD file system, not my file system. So we can do path from, path to, and we can also pass copy options, which are what exactly? Skip existing, override existing, recursive, copy symlinks. So there's a number of things here. We already know that the file doesn't exist in the branch of the code that we're on, so we don't need to worry about skip existing or override existing. So we don't need copy options. So we'll use the first version of this. The second version of the first version of this, if you provide the error code object, then it doesn't throw exceptions. Yeah, so that'll be what we need. So if it doesn't exist, first we want to confirm that the backup path does exist. And I'm actually going to use the exists call from my API and just pass backup path straight to it. And I'm doing it that way because it automatically converts from virtual path to native path. So we'll say if exists backup path, then we'll do the copy, or we'll attempt the copy. Else, we've got a problem in which we can't actually open the INI file or the backup. So at this point, we would no longer be interested in parsing because we have nothing to parse. We would return error code. Error code. I guess error code does not exist because this would be both files not existing. So if you were in such a situation where you find that the original and the backup are both gone, you can handle that if you want. Like maybe you would like hard code a function that would create the original file over again, which might be a bit much if you're talking about a file that should already be in the installation folder. But it might be a good backup if your game encourages people to go in and hack apart INI files. Because if you handle this by just writing out the default value from hardcode again, the default INI file from hardcode, then you have a way to protect gamers against themselves, or from themselves, for modding their files. So at this point, we would return error code does not exist. I don't think we need to do much else. Let's do a warning or an error. And for the moment, I actually have to copy the function name whenever I'm doing this. I'll probably fix that at some point down the road. Do not open file. And then provide the original path. I'm using mpath here because that's already in the native file system format. And then I'll need to convert the backup path to virtual file system. So vpath to native path, like that. And now we've got a warning telling us, or an error saying that we can't open the path or the backup path, and we're saying exactly where they are on the computer. Sometimes I prefer to indicate the errors with the virtual path. This is a case where I want to tell exactly where it is on the computer, because it might involve permission issues, for example. Actually, it can't involve permission issues, but whatever. Whenever I'm dealing with open problems, I pass the native path. I think maybe it's like a disconnected hard drive or something. Anyway, exists backup path. Yeah, and then in here we need to try to do the copy. So now we got std file system copy. Copy underscore file, is that different than copy? Copies file contents. I don't need that, I need copy file. So now we got the from and the to path. And so the from path is going to be, that would be vpath to native path, backup path. And then the to path is, path, like that. But I also need an error code. An error code object, that is, you see, to pass into here for a couple of reasons. The first is that it prevents copy from throwing an exception if there's a problem, and it gives me a way to handle it. Let me check where I've used this in the past. I know that I've used this in my file system recently. Oh, I've used it in exists. Okay. Yeah, so we get the value in the message if we have an error. And the proper thing to do is to say if error code, because it has a Boolean conversion that reports whether there's an error in there somewhere. So let me copy that out. Boop. If there's an error code, let's change what the message says. In this case, it would be INI reader open. Error copying. And I guess that would be enough, but I'm not sure that I actually want to abort the read at this point. Because we still have the backup file. We can still read the backup file. So what we could do is we could just open up the backup file instead at this point, and then just parse the data that we're asking for out of it. And that would work fine if all we were doing is reading. But thinking a little farther down the road, remember that I'm going to want to be using INI reader as a component of the writer when it comes to merging INI data versus just overwriting the whole file. So let's go through that scenario again. If you were wanting to write only specific sections of an INI file, so you're only replacing the specific INI keys that you chose to write, or the INI sections that you chose to write, you would, all of that stuff would be written to a temp file. And then when it comes time to close, the INI writer would open up a second temp file. That's going to be where we actually merge the data. It will open up an INI reader on both the first temp file and the second, and the destination file. And it would go line by line and compare those. Actually, it wouldn't be an INI file reader, it would be a text file reader. I would need to have special parsing for that, because the INI file reader doesn't go line by line. It just parses the whole thing. So the text file reader would go line by line, identify when things need to be merged, and when they don't. When they don't, it'll be a little bit of a complicated algorithm, but it'll go through and make sure that only the things from the right files is being written to the output file, and then that second temp file is moved into the destination to replace the destination file, and then the first temp file is deleted. So how does that affect this? If we don't have the original, then we actually don't have anything to merge with. So the merge algorithm would essentially receive nothing. We would need to design it in such a way that it doesn't, that it only sees an empty file. Which might mean I need to tweak the text file reader. Because if the text file reader attempts to open up a file that doesn't exist, I want it to be able to call read next line on it, or have the end of file bit set. So that way it can quote unquote compare the two files even if one of them doesn't exist. It'll just treat the non-existent one like it's empty. Yeah, so actually there's no problem at all if we just continue to read the default. Because later on, if it comes down to writing and merging, it will be comparing the default file against the file that you're writing, and it'll merge those two without harming the default file. Yeah, so at this point, if the not at this point. At this point, if we can't copy the file over, we could still proceed as normal. But we would run into a problem at the end of writing the merged file, and we would have to deal with that there. Which technically we have to deal with that situation anyway, if it's not possible to read the contents of that file. Yeah, I guess that's that. Yeah, so what I'll do here then is I will go ahead and reattempt this operation by opening the backup path. So ini dot open backup path, and then we will do error checking here. Error code equals ini dot open backup path, and then I can use that to check for its problems. So we already know that the file exists. I don't need to check does not exist. But I do need to know if it's successful. So if m error code equals, or doesn't equal error code success, then we also can't at this point, we also know that we can't open the backup file. And at this point, if we can't open the original or the backup file, then we need to return error code. Well, we'll need to return some error code. So we'll deal with that handling in a second. Error code. Cannot open backup INI. And in this case, instead of doing that error code, we need to pull an if-def, or we'll do a switch for error code. And let me just generate the missing case statements. Okay, do I not have? Oh, I don't have the option to refactor that and put in, yeah, that might be a visual assist thing. Case code. We already know that it must exist because we checked it exists earlier on. Null doesn't mean anything. Permission failure and unhandled are the only two that we need to consider here. Unhandled is the catch-all error code that I have for if there's a problem that doesn't line up with the error codes that I've handled. Or actually, I forgot that I actually have a helper function made for this situation that I forgot about that I'm going to use instead. Error code toString. I can actually just do this, which is actually easier because I don't have to write an if-else statement. It's enough for me to know that it's not successful, and then I can print what the error is. Error code toString. Let me review that. Yeah, I don't need to. I'm not gonna modify that. Cool. So INI reader open. These should be capitalized. Cannot open backup INI. We'll get the error code toString. And print that out here. And we need to return the error code. So I can actually just return the error code directly. And this will be the status of the failure to open up the backup path. Okay. Good. I think that covers all of our bases for opening scenarios. So first we try to open up the original file. If the file doesn't exist, that's not necessarily a problem. So we would first check to see if the backup exists. If it doesn't, then we return does not exist. And we say that we can't open the INI file or the backup INI file. However, if the backup does exist, we try to copy the backup file to the destination. And empath here is already in the native format. Then we check to see if there was a problem there. If we have a problem copying it, we report what that is. and then we will try to open up the backup path to read it instead of the original. So that way we would be parsing the backup file directly. And then if that doesn't open, we return the error code for that failure, and we press the message push the message to the console, cannot open backup INI. Now I'm realizing, reading through this, that I skipped a scenario, which is that the copy was successful. If the copy was successful, then we need to attempt to open the file again. So we need to attempt to open the original file path. So let's do that. And I'm going to put that in an else, because if the backup path opens correctly, I needed to skip this. So we'll do ini.open again. We'll do mpath for the pre-converted path. We'll set error code to it again. Then I will take and check for yet another error opening that file. There's not likely to be a problem at this point because we just created the file, so you think that it should be openable at this point, but you always want to cover your bases because there might be some other program and some other thread that's screwing with permissions right when you need to access the file. So what we'll do here is ini open. What do I do with the error code? I guess I just need to check whether it is successful. If it's not, then I'm not going to try and make a scenario where it will try again. I think at that point, we'll just report that there was a problem opening the freshly copied file, and then return. Cannot open newly created INI, and we'll do the error code to string here, and we'll return whatever that error code was. All right. Yeah, it suddenly got a lot more complicated just opening up the file when you have this backup file system. But now we're at the point finally where after all of those opening checks, we know that the file has opened successfully, and that it is either the copied file or the backup file. Oh, you know what? I just realized a way that we can make this way simpler, and that is the fact that the contents of the newly copied file are obviously already going to be identical to the backup. So we actually don't need to try to open up the newly copied file. Yeah, let's take a look at that. Because if we have the backup path, we do need to copy the file, but we don't need to read it. So we don't need to check whether it opens. We can just continue to work using the contents of the backup file because they are identical. So we can actually reduce some of these checks. So if the backup path exists, we will do the copy. We should present a warning if the copy wasn't able to be made. So error copying backup file. And then we attempt to open here. So the difference is that we present the error, but we don't try to do the opening here. We just take that out and put it out here. Because no matter what we do, we'll just be opening up the backup path. And we'll say error code ini.open. If the backup path doesn't open successfully, we'll say we can't open the backup ini. Report that error, return. We're not bothering to try to open up the backup file when it would just give us the same data as the other anyway. So yeah, am I overlooking something here? Does not exist. It exists. If the backup exists, we attempt to create it. Else, we attempt to create it, and then we try to open the backup file. Okay. So this is the worst case scenario then in this entire branch, is that the backup file won't open, in which case we don't need to do any conditional checking here. Because we return in all situations where we can't get a valid opening, we don't need to check for error code success anymore. That's actually assumed. And I can get rid of that statement. And the ending brace down here. Let me do that. And then I hit the whole parser and say KF, and that'll bring it all back. Cool. All right. We're making some headway. Cool. So at this point, we know the file is open. And then the parser can just proceed like normal. So the only thing left to worry about from the parser's perspective is the section filter, which is no longer a single string, but a vector of strings. Okay. I think I'm going to need to take a quick break and then come back to the stream. But when we get back, we're going to want to update the parser to use all section filters in parameter. So whereas before we used to just check whether it was a group or not, and then parse in light of whether the filter that we're dealing with is in the group. We need to update the parser so that it will check each section filter and either add it or not add it based on whether it was passed as a parameter. All right, cool. Gonna take a quick break. Probably be 15 minutes this time. Alrighty, I'm back. I had to take a quick minute. So when we last left off, we had gotten through the complicated procedure of ensuring that we have a ensuring that we have a valid file to read. So procedure used to be that when you try to open up a file, if the file doesn't exist, then you're shit out of luck. But because these are INI files, they're configuration files that are designed to be changed and updated on any given PC or Mac, we needed to have a more robust way of handling that scenario. So if you're on a new installation, for example, you could, like in theory, in an installer, automatically populate the app data for each user on the machine. But then what happens if you add another user, right? So the quote unquote correct way of handling this, I've decided, and I'm sure this is the way that a lot of other apps work as well, is that you first attempt to load the file from the working copy, the copy that's in the app data folder. If it's not there, then that's not an error. If it's not there, then you simply copy over the file from the installation folder, and then you have a base to build on. So we've handled all of that here. We will try and copy the file over. If for some reason the copy the copy doesn't complete, then we will actually still be able to read the backup file. We just proceed from there with the warning on the screen that we couldn't create the duplicate. We'll just worry about when we go to use INI file writer, we will care there that the fact that the file doesn't exist. And then if for some reason the backup doesn't open either, we will handle that too. So at this point, anybody who's using the INI file reader, if they get an error code that's not success, then they know that there's a real problem in that they are not handling their controlled copy of the INI file correctly. Cool. So now that we have gone through all of that, we need to consider the question of section filters. Now this parser is just not very efficient at all. I'm going to need to go through it again, because if memory serves me correctly, there's a whole bunch of allocations that don't need to be there. Let me double check. I might be confusing this with one of the parsers I wrote for hot constants. Basically we just read the next line from the INI file, and remember this is a text file reader, so this is not using any of the methods we worked on today. We just get the string for the next line. We set pause equal to the find first not of space. That should actually be space or a tab. So that actually should be space or a tab. I probably shouldn't go through the parser all the way through right now, or maybe I should, because this is actually not as complicated as I remember, even though it is pretty complicated. Parsers are basically just a big long string of if statements, to be honest. They're not amazingly complicated sometimes. But the question was, do we do too many string allocations? You know what? I'm surprised to say that the answer doesn't look like we do any string allocations. Was I good? Was I good when I wrote this parser? Yeah, because these are the first string allocations, and they are necessary because we are pushing them back into the map. the data map where we associate the keys, or the sections and the keys and the. I think I did a good job last time. I mean, this has still got some problems, so I'm going to need to go through it again. But yeah, it doesn't look like I am allocating strings everywhere. Strictly speaking, I am allocating each string as I read it from the line. That sort of comes with the territory, I suppose. One way I can make this a little bit more efficient would be to simply read the whole INI file into memory at once. So instead of using INI reader, text file reader, instead of using it, I would just use like load text file, which just takes and straight up dumps the data from the file, the entire contents, into an STD string, and then parse it that way, which might be marginally faster, but who knows how long an INI file might get. So yeah, I think this is actually pretty good. I don't have to worry about all those string allocations being a problem, because the only strings that we're allocating is when we call a line substring, and that's when we're pushing it into the to the data that we're tracking anyway, and we're actually okay with that because it's using in place back, so it's constructing in place, so it's only one to one for every value. Yeah, that's pretty good. All right, heading back to the section filter question now. We are no longer using the section filter thing up there. We are now going to use valid filters, because what I had done was I had gone through the list of section filters that we provide, and then pushed into valid filters only the filters that met the alphanumeric requirements, meaning no spaces, no strange characters, only letters, numbers, underscore, hyphen, and dot. Previously, I would assert that it didn't have any white space in it, and not like enforce the style of alphanumeric plus those three characters. And I would check whether filter is a group up front. So what I think I'm going to do, at the time that I check for valid filters, I will check for whether it's a group. So I'll do an index aligned vector. Is filter a group? What am I doing? I need to do it like that. So now we got an index aligned vector. So if the filter is alphanumeric, then we can put we can do a check to see whether the back character is a dot. That said, something that this scenario does that this scenario does that the previous scenario didn't is that it disallows white space entirely between square brackets. Let's go back to example file. So previously I supported this. You wouldn't be able to put characters like spaces in the string itself, but if you wanted to put white space in between the section names, like maybe to like make them line up or something, then you could. I don't know why you would do that. So I guess I'm okay with adding that restriction, so that when you go to read or write a INI file, you are forced to just do alphanumeric in between square braces completely. And that may simplify the parser a little bit. Not that I'm going to bother with that at the moment. So yeah, I think that's just a requirement that I'll take on. We are already checking to confirm that no leading white space or trailing white space is allowed. And we are preventing the... Yeah, okay, so that's what we want. So now we just need to check the back. We've already confirmed that there's no white space in the back, tabs or spaces. So we would just do if valid filters dot back, getting us the last one dot back, getting us the last character, back dot back, back to back, equals the dot character. Then we will treat this as a group. Actually, to be a little bit cleaner, I'll do is filter a group dot pushback, and what we'll push back is the Boolean result of this check. Bam. This technically allows for weird situations, like if you put 2 dots at the end of a filter. So if you put 2 dots at the end of a filter, what would happen would be the filter would be checked sans the dot against every string. So that would mean that this would be a valid section name. And I guess there's nothing wrong with that. It's not breaking anything. So I'm not going to bother with any rules about that. So now we've got an index aligned list of whether the filters are valid or a group. I could make this like a pair. Actually, I'm tempted to make it a pair now that I'm thinking about it, because I would put the data right next to each other in memory that I need as I'm iterating through. Yeah, let's make that a pair. Instead of doing index aligned, I'll do valid filters. I'll make this a vector of std pair, where the first is the string and then the second is the bool about whether it's a group. And then we'll push back the filter if it is alphanumeric. And then at the same time, we push back the results of this check. Right? Does that work? Valid filters. Except for now, valid filters dot back returns a pair, so this isn't probably going to be very readable, but it is going to work a little more efficiently memory-wise. The idea is that later on, I'm going to be iterating through the filters anyway. And so when I iterate, I'll have both the both the name and the group status of the filter, and those are coming from the from contiguous memory. So it's not referencing 2 different points in memory when I'm working there, which is just a little bit of a smarter way to do it. So we'll say first is filter name, second is group name. And did and previously I didn't remove the dot, and that makes sense because then I can just check for the whole thing, including the dot, when I'm looking through the list. All right, perfect. So that's done. Underneath the section filters, qualified section. I guess I'm going to have to go through the parser in order to even implement this change. So I guess I am going to have to do the parser, whether I'd like to or not right now. So in qualified section, Unqualified section means what exactly? I didn't pick a very good name for this variable, apparently. I'm guessing qualified section refers to whether we are tracking whether we are in a section that we want to read. So if there's no filter, we just set it to true. And then we set it to false up front otherwise. So that way we are skipping the global section, meaning sectionless keys is what this is. So in qualified section, probably not the best name for it, but the idea is that in filtered section might be a better name for it. The idea being that this is a section that survived the filter. Yeah, let's rename it that. So now it's in filtered section. Section filter dot empty. If section filter dot empty. Previously, section filter was just a string. So empty might have been a weird way to call that. Because empty, I guess it's just a bool for whether the size equals 0, but it's not very clear looking at this. I probably would want to say dot size equals 0 or whatever. But this is no longer a string. We need to do a vector of strings. So how would we best approach that? So at this moment, our objective is to mark whether we are currently in a filtered section. So if we're providing any filters at all, then that means that we are skipping the global section. So actually, we could just do section filters.empty here. And it makes more sense for the call now that we are using section filters as a vector of filters. So if we don't have any section filters, then we are then everything has survived the filter. We are going to take in the keys from the global section. Otherwise, these can just be one lines. My C++ style tends to be a little over the place, not necessarily consistent. But one of the things I do is I will be okay with one line after if. Some companies, they prefer that you do it like this every time, which is like maybe a little bit more readable, but nobody's going to be confused looking at this, in my opinion. If section filters.empty, in section filtered section is true, else is false. I could actually simplify that a little bit further and say in filtered section, when I go to initialize it, just set it equal to section filters.empty. That does the same thing. Cool. And then I'll put a little note of what we're doing here. If there are no filters, we will take in keys from the global section above the first section header. Make that a little bit easier to understand in hindsight. So we're in filtered section. And then going through the while loop, we'll go until we have reached the end of file. So if it's an empty file, it actually just skips this. I'm pretty sure. Yeah, because that's handled by IF stream now, so it will just be end of file if the file is empty, I believe. Yeah, so if we're not end of file, then we'll do ini read next line, and we'll get the position of the line will start at the first thing that's not white space. So if somebody puts a tab in here or a space or whatever, we don't start reading the key until that character. All right. Okay, if the position does not equal std string end position, meaning that if we find something on this line, then we will proceed. Otherwise, we just continue on to the next line in the loop. We check to see whether this is a section header simply by checking the character at position. So if we have a tab or a space before the section header, it will start there. So that's how we handle section headers. And because that's where section headers are handled, I don't think we care about the filter list here, do we? I don't think we do. Because the filter is whether we listen to the value depends on whether we're in a filtered section, and that's determined up here. So when we find a new filter, we determine whether it's inside of a filtered section. Cool. So we're going to be operating in here. This might be a section. We look for the closing square brace. If there isn't one, then we find an invalid line. The invalid line comes from the idea that if you find a line that starts with a square brace but has nothing else on the line, that's invalid. INI files don't allow you to do line breaks inside of a section name, or even within a key value pair. So let me review that warning. This doesn't meet my standards anymore. My standard is to do the name of the function. And eventually I'm going to have this automatically pull the function name when you're using epwarn. INI reader open, invalid line encountered in INI file, path. Path, because path points to the destination instead of the file that we're necessarily actually reading. I'm not sure if that is what I want. Backup path might be what we're using. So do I want to track then whether the path or the backup path? I guess so. So I guess what I'll do is I'll track it up here with a bool or something. Yeah, I guess that's how it's gonna need to be. Bool. So by default, reading backup file is false. And then if we do INI open on the backup path, we will set that equals to true. And if the file doesn't open, then we're returning anyway, so that's a safe place to say it's true. And now we know whether we're reading the backup file or not. So heading back to the error we were working on, invalid line encountered, line was skipped. Instead of path, we would say, I guess in parentheses, do a ternary operator, and then we'll do path if, or backup path. We'll do vpath to if path for backup path. If we are in the backup path, and we'll do mpath, which is pre-converted to be the absolute path otherwise. Cool. All right. So now we're doing this, and I'll put that on its own line. So we got the path and then the line number. Good. That's a good warning. Now, if in the case that we encounter an invalid line, then we are just going to skip the rest of the line. So this includes if you did something like that. If you did something like that, then the whole line will be ignored. Good. Now heading back into the parser here. At this point, pos 1 is pointing to the the opening square bracket. Pos 2 is pointing towards the closing square bracket. And now we are looking for leading and trailing white space. I was saying before that I think that I'm going to disallow that. But you know what? Why not? I've already got the logic in here, it looks like. So it's already going to, what it does is it just moves the pos, which is pointing at the left side of the equation. It's pushing it to the first thing after the left square bracket. That's not white space. But to be more technically correct, this needs to be a space or a tab character to check for a white space. So it'll find the first thing is not white space. And then this will be find last not of, rewinding from the right square bracket, finding the first thing inside that's not white space. So the first thing that's not white space might be the end of the string. Or I suppose it could be the left, if you have empty braces, it could be the left bracket. Do I handle that? I don't check for that. So actually this is a potential error condition in the parser that I haven't checked yet. I am just assuming that whatever between the brackets is valid, even if it's nothing. So if it is just white space, then pos 1 and pos 2 will be... Oh, they'll find themselves on the opposite sides. Okay, that's a problem. So what I'll do here, I need to ensure that, because if I have white space here, what'll happen is, in the attempt to remove white space, I will search for the first thing that's not white space, find the right bracket, and so I'll say, okay, the string starts here. The name of the section starts here. But then the pos 2 will be searching backwards from that, find the left bracket and say, okay, so the string ends here. So it'll say that the string starts here and ends here. That's wrong. So I need to handle that. Because I know that everything inside of the section must be alphanumeric, what I'm going to do is I'm going to simply check whether pos 1 is pointing towards the right square bracket and check whether pos 2 is pointing towards the left square bracket. And actually, now that I'm saying that, I actually only need to perform one of those checks, because by definition, if there's nothing in between left and right bracket, then both checks will be identical. So what I'll do is I'll need to do if pos equals, I'm going to do this up here, if pos equals pos2, which would mean that when we did the check from pos to the end of the white space, it is equal to the position of the right bracket, meaning it's just white space. And we'll do the position rewind in a minute. So if they are equal, then that is an invalid section header. I'm going to disallow it. Well, should I disallow it? Let me think about that. Because one way to interpret this situation is that maybe the dev wants this to be in the global section again. That's interesting to think about. So, for example, what if somebody is working on a file, and for whatever reason they want the ability to put things back in the global section after they have already outputted other sections. One thing that they might want to do is that. Make a section that doesn't contain a name. And then everything underneath this would be the section above. That would be one way to interpret it. For that matter, that raises another question. Do I want to be able to do duplicate sections just so that you can add more keys later? So like, what if I did, if I serialized input.context, then later on serialized other keys. So like, instead of doing the keyboard mappings, I would after reading out multiple sections, I would do the gamepad, like you know, face button left or you know, like D-pad, you know, left or whatever, and then handle gamepad and keyboard bindings like in their own sections. I think that would actually work, and I think that's partly how it's already implemented. So I wasn't considering the possibility of an empty header before, because the way that the code was written before was that I was just assuming that there was something in between the left and the right square brackets. But whatever string I get is what I will check against the filters, even if it's an empty string. And then once I have identified the section, then I use that to write the values to the data map internally. So internally, the file reader has a thing called mdata. That's the wrong reader. This guy has a map called mdata, and that associates the section name and the key name with the value as a string. So no matter what, I'm pushing key value pairs into the same section, even if they're out of order. Yeah, okay, I kind of like that a lot. So here's what I'll do then. Instead of making this an error condition if it's empty, I will simply make it an empty string. So the way that I'm going to do that is by only rewinding pos2 if there's a character in between. So if pos1 starts out at the character that's the left square bracket on the section line, and pos2 starts out at the right bracket, I will first do the search for non-whitespace characters from pos1, effectively moving the pointer to the right. At that point, if there's nothing in between, then they will equal each other, and I don't want to rewind pos2. So if they don't equal each other, that means there's a character in between, and I do want to rewind pos2, and that'll ensure that either it's a zero length string between pos1 and pos2, or that it contains a string without leading and trailing whitespace. Perfect. Okay, I think that's exactly what I want. And then take a look at this. Now, this code assumes that we have only one filter. So at this point, we need to iterate through the valid filter list and compare the string between pos and pos2 with each filter. And I think that's all. If filters in a group, else. Right, so yeah, so that's all contained in here. Infiltered section equals true false. So at the end of this block, we will know whether it's a valid section by whether infiltered section is true. We actually keep that bool for future parsing, so that way we can compare against it for all lines that are not section headers. Good. Okay, and what is this block doing? In the case of sections, we err on the side of using the section name, even if there are invalid characters after. This is referring to characters that are located after the right square brace. So if we were to do something like that, we want to issue a warning saying, hey, you've got garbage in your file, but we don't want to cause any problems. So at this point, we've already done the parsing work. Again, that's another goof up. I gotta correct space or tab is what we have to check for. And there's another problem with this, which is that it is finding the first knot of whitespace from pos2 plus 1. And pos2 now points to the last character of pos2 plus 1 points to the first character after the section string, which is not necessarily the right brace. So we want to make that check somewhere else. Probably up here when we first do the sorting. So oh man, yeah, I guess I'm just gonna have to redo the parser on the strip, because if I don't go through and redo the parser, then I can't implement the new section filter list the way that I want. So I guess we're just gonna have to do this whole thing. And we're encountering some of the problems that were in my parser from before when I hacked this together in the first place. So going through the file, we first check to see whether the first character is a square brace, and if it's not if the first character is not a semicolon, then we check for key value pairs, meaning that if it's not a commented line, then we check for key value pairs. I need to check for semicolons within the section name. And I haven't been doing that yet. So actually what I need to do, after I have found the first character and confirmed that it is the left square brace, I need to also check for semicolons. Which means we're looking for the right brace, we're also looking for the semicolon. So I'm going to plug that in here. Well, that's interesting. My phone's telling me that I got a new follower, but I don't see in the history who that was. It says I got 11 now, and the last I looked I had 10. So thank you, whoever followed. Yeah. So position 2 is going to be either the end of the section name, or it's going to be a comment indicating. So like if we have a semicolon in the middle here, that would indicate the end of the line. Wait, wouldn't it? That's interesting. So like if I press a semicolon in the middle of a key, the linter on Visual Studio Code is telling me that that ends the line. It turns the rest of the text green. But I just noticed that when I did it here in input.context, it does not do the same thing. Maybe this is why I skipped it last time. Maybe semicolons are actually valid in section names. They're not valid in my opinion for the purposes of my writing and whatever. I just want dots, dashes, and underscores, and then alphanumeric. And that's it. But I guess the linter doesn't actually care about semicolons. Probably fine with these other characters too. Anything except for another square brace. Yeah, so I guess maybe I don't need to watch for the semicolon. What I'll do instead is I'll just confirm that. Yeah, I'll just confirm that the string is alphanumeric with those 3 exception characters before I do anything with it. And that'll be enough. All right, cool. So we find the thing, we find the first character that's not white space. We confirm that. That this doesn't make it equal to position 2. And then we rewind as well. Okay, which actually means that we're back to where we were before. So this is going to need to be wrapped in the loop for the filter, the valid filter sections, or section filters. And this check needs to go after finding pos 2. Okay, because at this point, pos 2 is either equal to, it's either pointing towards the right square brace, or it's pointing towards now at this point it's either pointing towards the character immediately preceding the square brace, or the character preceding the white space within the square braces. So this has to go above even where it's at. This needs to go up here. before we even remove the trailing white space. So that way, at this point, pos2 is still pointing towards the right square brace. Now we can start the search for non-white space after the right closing square brace. All right, good. Pos3, I'm not going to rename these right now. Pos3, if pos3. So this means that pos3 has found something that's not white space following the right square brace. And we're checking now whether that equals the semicolon, which means that it's an end-of-line comment, which is fine. If it's not an end-of-line comment, then we will present the error. Okay, so this logic works great. So what we need to do is copy that function name, replace this guy with it, and reader open, invalid characters encountered after section name. And then I don't actually provide the section name. Let me do that. After section name, there. Characters after blank are discarded. I'm going to say ignored. And then we'll do file line. And I'll put file in quotes because that's slightly better. There we go. File and then line. So path, line, and I need to put the section name now. The section name actually hasn't been determined yet. I'm not actually ready to generate the section name here yet. So what I think I'll do is instead of doing the warning, I will do yet another temporary bool. To track whether there are garbage characters. And then if we wind up in this situation, we'll set garbage follow section header equals true. And then we can proceed like normal. We could get after we've obtained the string, we can then generate the error. And actually, this will prevent a duplicate error because if there's garbage following the section header, that's secondary to an invalid section header or section name. So we'll do that check only if. No, we'll do both checks, but I need to do this after we've got the string. Anyway, so at this point we've got the loops. Let me quickly check what the logic is for if if we have a match. First of all, we increment position by the section filter dot size. So section filter is right. Section filter is the first section of the name, and we stored that in the valid filters list. past that, we generate the substring from pos, which is now the position of the first thing after the section filter name, and we make it the length of. So we make a substring from pos from the start of the first character after the filter name to the end of the string. Pos2 being the point. I think this might be wrong, because at this point, pos2. Oh no, I do add a +1 here. Okay, so pos2 is actually pointing towards the character after the section name. That's perfect. Good. Okay, that's exactly what I want. And then from here we do it. So the line substring is determined from pos and pos2. And those are already set correctly here. So at this point, we just need to wrap this section in a loop through the valid filters. And yeah, so we'll do a for. In this case, I'll do const auto and do a structured binding as well. Structured bindings are, I've said this a number of times, they're a great C++ 17 feature for these sorts of situations where I just want to have the names of each of the, I want to have names for each of the variables in the pair. And that pair was called, valid, or was it? Valid filters. So the first is the string and the second is the bool. So valid filters. So the first is the filter name, and the second is the bool, which is whether it is a filter. Is filter. So I guess it would be section name and that in valid filters. So if it is a filter, so if this is equal to false, then this is just a section and we're just doing a direct comparison. Otherwise, we are doing the substring and comparing it against the list. Okay. Good. Yeah, I think I've got it all straight in my head. It's sort of hard to hard to track parsers sometimes because you have to kind of think through a whole bunch of potential scenarios that sometimes aren't obvious. Cool. So we got the section name, we got the filter. In this case, if filter is a group, is not a variable anymore, we just use this. If isFilter is true, then the logic we're going to be working on is on the first of the pair, which is now called section name. So let's check the readability of this. So we've got, if it is a filter, then we will, pos1 is already pointing to the first character, first known whitespace character in the braces. Pos2 is already pointing towards the character after the last thing in the braces. So we'll do line.find from pos. And if it does find it, and it equals pos, meaning that it's the first thing on the line, then we will move on. Actually, I can do this a little bit more efficiently. I'm going to do rfind instead, and I think I pass 0. I think that's how that works. The idea is that instead of searching the whole string, I tell it to essentially search for a string starting at exactly the beginning. That's an efficiency trick that I used elsewhere, and I'm trying to remember where I used it so I can just copy it. I think it might have been in file dot. Well, let me first search this file. Nothing in this file. Let's look in currently open files. Oh, rfind, not find. Yeah, not in the currently open files. Let's restrict it to current project. That's not in my project. File. Yeah, so I used that trick here when I was using vpath to native path. Because I'm checking more than one character at once, I did rfind for that string, and the position that I'm starting at is 0, meaning that it first checks to see whether this string starting at position 0 is equal to c/, or if the first if that's the first instance of c/. If it's not, then what it does is instead of using find and continuing, it actually finds it, or doesn't find it, and then goes backwards. And because we're already starting at 0, it just stops there. It only compares the first character of the string. Though now that I'm looking at it, if we do line.find section name and we're looking at pause, the downside here is that we don't have the ability to avoid searching either way if we use line.find. Because line.find will start at the beginning, go to the end, search search the whole thing for section name. If we use rfind, we're no longer starting at 0, so it may still check all of the characters before, and that doesn't help us either. So this works, but in the spirit of non-pessimization, I think it'd be a good idea to do this more efficiently. So what we probably should do is create a substring or string view. A string view is just a handy little wrapper that allows you to construct something that kind of looks and acts like a string, but it's actually just referring to a buffer you've got somewhere else. So a string view you can construct from an existing string, and then treat it like a string, but it's not actually constructing a string anywhere. So this actually is really handy for parsers. And I use it in my GLSL parser quite a bit. So I'll construct a string view from position 1 to position 2. So that'll be I'm gonna take this moment to rename this. Section name is probably not great. Let me do filter name. Might be better. Yeah, we're only replacing within this group. Okay, good. And then I can do something called section name or section text. text is probably more clear, and construct it. If I'm remembering my string view constructors, I think we pass the string the first and the last. String count. Or is it the other way? Is it from std? It might be from string. Yeah, operator string view converts it into a string view. I'm going to quickly see how I used it in here for an example. Yeah, so what I did in this case was I used source.data to get the actual C string, the actual underlying buffer from the source string. Then I offset it using the number of characters we were in. So we got a pointer to the first, and then we needed to find the length. Okay, yeah, makes sense. So we were actually using this constructor here, where we got a car T pointer and so basically just a C string out of the data from the other. So the section text here is going to be line dot data plus pause 1, which doesn't have a number on it, but plus pause, because pause right now is pointing towards the first character. Yeah, first character of the text. And then it will be pause 2 minus pause characters long. Okay, so now we've got a string view that there's no allocation going on, but we can use the string view to compare against things. And I don't need this in the other branch, so I'll just leave it allocated right here. Now I've got the section text, and instead of doing a find to see whether filter name is in the string somewhere and that it equals pause, I will then do rfind, and instead of searching filter name or searching line, I will do section text.rfind. So section text contains or points to just the section of the line that contains the text that we care about. We are searching it for the filter name from 0. And then from 0, if it finds it, it would be, how did I do it here again? Find equals pause. That's the one I was just in. That was in file, that's what I was looking. Equals 0, meaning, yeah, because if it's not equal to 0, then that's right. Head back to the code. I'm not probably not voicing my thoughts very well, but this needs to be equal to 0 because the section text already starts at pause. So we're checking from it its starting position, which is pause, whether that is the start of filter name. And then if it's not, it doesn't actually continue to iterate through the rest. It just stops right there. Oops. And that's that. So if section text, if we don't find the filter name there, so this is all a fancy way of saying if the string doesn't start with filter name. Then we will advance the position by filter name.size, which is this one. We will set the section variable, which is this hash name that we are tracking while we're parsing. We'll set that equal to the hash name of line.substring. I don't have. I wonder if I can get away with using the string view here. I didn't make a hashing algorithm that specifically accepts string view, but I do have one that accepts C strings. So I could do section text dot C string, no, dot data. I guess I'd do dot data and then section text dot size. That seems to work because I have the constructor for const car literals, which the overload will pick the pointer to the string and then provide the length of it. Okay, and then we don't have to do an allocation when we go to hash this time. We just do it straight from the memory of the already allocated line. So we're reducing an allocation. That's always great. And then section is now a hash. We'll push that into these sections. But there's a problem there, which is that this does not consider the possibility that I might have duplicate section names. Because this is a vector, I think I'm going to implement this as a set. And what that'll do is it'll make it so instead of being a list of all the section names, including duplicates, it will only contain the one instance of each section name. So this will be sections dot, I think it's in place, or is it insert? I think in place can do it. But I'll call insert in this case because this is not a constructor, it's a variable that already exists. Cool. So an M sections is used specifically for a retrieval function. So like this is used for parsing. We need to know which section we're in now. And this is a list of all the sections that we have parsed. And we use that when we want to get a list of all the sections that did get parsed. And that's useful in, for example, when I'm using contexts, you can put whatever name you want for your context here, and the input system will get the list of all the contexts within the input section and name a input context after all of the section headers. So that's a cool use case of that. Yeah, and then I think we're done here because that after this, the only alternative cases don't involve hashing or doing rfind. So because if it's a filter, then we have to do that comparison on the first part of the string, and then hash the section name. If it's not one of the if it doesn't match at all, then we are skipping parsing for the section anyway. We just set to false. We set the section name to null. And if we're not in a filter, if we're looking for an exact match, then we just do a comparison here. Filter name equals line.substring. But it's occurring to me now that we can actually get rid of the allocation that happens here as well by using this trick. Because this is the same logic actually. We're checking to see whether filter name, which is a string that we calculated at the start of this call, we are checking whether it is equal to the string that exists between there and there. If we instead did section text as a string view, I'm going to move that outside of the scope so it's available to both sections of this if statement. We can just say if filter name is equal to section text, because there's a comparison operator between the string view and between string views and strings. So this is a string. When we compare it equal to section text, it's still doing that one-to-one comparison, and string comparisons are by their nature not very fast. But it isn't allocating a new block of memory for the string anymore. It is just using the string view, which is simply looking within the line that we've allocated when we read it from the file. So we just removed an allocation. That's great. Awesome. And then from here, we've got everything under control. This section we don't need to deal with because all it's doing is it's parsing the lines that are not related to the sections, and we made sure that it has access to all the data that we need regarding the sections that we're parsing. Cool, so I think that's it. I think that's this one in a nutshell. Now, coming back down to these functions, we'll see that there's all of the getter functions that we've already written, and we still have to write more. But the ones we've already written are giving us red squigglies. And that's because these used to be getters in the API that I commented out, because that's this stuff, because I didn't want those to be publicly exposed anymore. However, they still serve a function when parsing. So let me uncomment those functions. Right, these are them. There's so much commented stuff out now that I'm second guessing myself. Yeah, so this is I9 get string to bool, get string to float. Yeah, I guess that's all valid. Uncommenting those. And now these are giving me red squiggles because they're no longer part of the file class. So for these, I just want to keep them for the purposes of parsing, but I don't want them in the file scope, and I don't want them to be linkable outside of this translation unit. So I'll mark them all as static and take off that file qualifier. Like so. And just for my sanity, I'm gonna put a line break between each. Okay, and if we look down at the bottom now, each of the individual value getters, they are no longer showing warnings. Get dictionary is, and get multi-dictionary is, but that's for a separate reason. That's because these no longer match the signatures that we put in the header. Return M sections. Oh, you know what? Changing the M sections to be a set instead of a vector caused a few problems, so let me straighten those out. So now the sections getter now returns the set for you to iterate through. And actually, I'll do that by const reference now. Okay, all right. Cool. So we're back on track. Get it, get multi-int are still implemented. Same with go float and get multi-float. Bool, multi-bool, string, multi-string. I have a bunch of new getters though that I planned to implement that I haven't yet. And now those are the next on the chopping block for things to do. Well, they're not the immediate next thing, I guess. The first thing to do would be to fix the get dictionary here. So get dictionaries, new return value is the INI, the map between hash names and INI value t, which is that type def for the STD variant that we're using. Do I want to put this in this whole thing in the namespace? I don't think it's worth it. This is like the only time I've had to use enterprise : in here because all these functions are basically within the file scope already. And then get multi-dictionary I need to change as well. Here. Right? Map of, yeah. Wait, does that work? Yeah, it doesn't. INI value 2. And then probably the parameters are messed up now. Section key. Yeah, now we accept initializer lists, unordered maps, and maps of the subkeys. So it'll list which subkeys we want to read and what their types are. Yeah. So that value's got to change. I'll start with the map implementation. That's getting a little lengthy. Yeah, that's probably as good as I'll get readability-wise. That raises a question that I hadn't thought about until just now. Does this make sense to have subkeys set up this way? If we're getting multi-dictionary, the presumption there is that all the dictionaries are of the same type. That is, they all have the same subkeys. And I think that's a reasonable assumption. Because you always expect the the key to be of a particular value. So yeah, that works out fine. So we can just provide the same association for subkeys for multi-map, even though it's going to be applied for multiple keys, for multiple actual main keys. Cool. Now we just got to get this so that it's not breaking when you go to compile. And then I think I'll take a break and maybe move on to something else before we bother with the other getters. Okay, so the first thing that we got is we make an unordered map for the return val. That's no longer correct. The return val's got to be one of these guys. And the first thing we're doing is we're checking to see whether the key we've provided was parsed from the file. This is actually an incomplete check because I am assuming that that section exists. So I actually want to do if mdata section dot size first, or dot count first, and then mdata section key dot count to confirm that those keys exist. And then we check the size. Let me do that. If count section and then if m data key is not equal to 0, and this seems like this logic has always seemed to me like it's a little wordy for what it does, but it's necessary. If you don't do this check for a count on the map or the unordered map, it will insert the section and key just by using the square braces here, which messes with the data, and that's not what we want. So we're checking whether those keys exist, and when we access them to get the vector, we know that it exists. We're checking whether there's any vectors in it. And then here we would use, I need to put this back inside the if block. Where it was. And then I'll do warnings here. Else ep warn INI reader get dictionary. Section name was not parsed from INI file. And then I would do hn2 string section. So whenever you use the hn macro to produce a hash name, that macro will intern the string. It only does this on debug and dev builds, but it interns the string so that you can, one, check for collisions, and two, unhash the string when you want to debug stuff. So for messages like this, I use hn2string. That'll convert this, which is basically just a 64-bit integer, into its associated string for printing. If this was used in a distribution build, it'll just print the hash as a number, and that's not great, but it's not nothing either, because if this somehow winds up being in a user-facing error message, the devs can unhash it on their end from customer reports. Yeah, and then return value would still be empty at this point. So yeah, we would. That's okay. Just to do the warning and nothing else. Now we need a similar warning for this key was not parsed from the INI file. We'll do the dehash of the key. I should probably put the section name in here as well. So it'll be key or section / key. So it'll print section / key for the message, so you know that you're looking in the right section for the key. Key was not parsed. And then this is if the it's occurring to me that this check is now unnecessary, because when we go to push back the data, we are only creating the section key combo in the event that we have something to push back. So this is, if there is already a section and a key here, then we are already guaranteed that the key that at least one instance of the key has been loaded. So I can actually get rid of this whole check. And we can just do the conversion here. So return val previously would just return a string, or so on. So in this case, we need to associate the dictionary string with each subvalue string with, or each subvalue hash name with the subvalue itself. Now it looks like before what I would do is I would just construct the return val from this guy, and that's not right anymore, because now its return value, it doesn't match the return value of this function. So what did I pass it? I passed it the data dot front. I used dot front here because in get dictionary there's the presumption that there's only one. In multi-dictionary, I would do a similar. I would do this call, but I would do it for every string that's in this section and key. So I'll leave that as it is. Let me finish up with rejiggering these warnings, and then I'll need to dive into this function and get it to return the right value. And that's actually going to be quite a bit trickier, because now instead of returning the string, instead of just looking at whatever string was associated with the key, we now have to do the conversion there and store it in the std variant, the INI type T. All right. So first things first, we'll do INI get dictionary for the warning here. So if we have a return val from get ini to dictionary that's empty, so actually these warnings occur first due to parsing issues when converting the dictionary. So converting that string into a dictionary and then getting its keys. And then if parsing was successful, then we check to see this warning should be elsewhere, actually. This warning is saying that we've got more than one string and you've called get dictionary instead of get multi-dictionary. That warning can be placed up higher. So actually I'm going to put that warning right up front. If data section key dot size is greater than 1, and we know that it is at least 1 because otherwise we wouldn't have the keys laid out to it. Then we would do EP warn and do ini reader get dictionary. We'd say file contains multiple, and I'll provide the name of the key. And then I'll provide a helpful message. Use get multi-dictionary. Use get multi-dictionary to read all dictionaries. I guess that makes sense. Or read all values. And then we'll plug in the name of the section of the key. And I guess I'll do that in the format that I did before, which is section slash value, or section slash key. So we'll do a new line here. hn2 string section hn2 string key. All right, and yeah, this is already getting quite wide. I try my best to keep code from getting wider than like 120 characters. Yeah, I think that's good. And then here I'll do the line break here. That should be good. All right, cool. And now we've got the warning. I can delete that warning. Then the parsing error. We're gonna have all new parsing errors now that we're doing this new conversion scheme. So ini string to dictionary is gonna need to return one of these. So I guess that's what we do next. And then after we've gotten the parsing figured out on this guy, on ini string to dictionary, which, yeah, it's probably going to be complicated because it involves parsing through the string and getting the comma separated keys and value pairs. Once that's done, once that's set up to return an STD map or whatever, then we'll be good to start implementing the other getters. So this might be kind of a 2-day project, probably. I don't think I'm going to be able to finish this today, which I don't like because it means that I will have I will leave the engine in a state today where it won't build. But this is just that large of a refactor. Let's go into get multi-dictionary real quick. See if we can get it set up. And then I will probably end the stream. I might not even do the remaining work on stream for the parser up here because that's just a lot of busy work and it's, yeah, probably better if I took some time to do it. But looking through this, we got the same problem with return val. Return val is not right. It should be a vector, but it should be a vector of type std map between string hash names and ini type t, or ini value t. Yeah, and then we need to do the same checks for section and key. In fact, in every way that matters, this code is identical, with the sole exception that we are not calling it just on front, but we are doing a loop, and we don't need this warning. So I'm just going to go ahead and copy the function body out. And replace it with this one. And then, oh, except for I need that return value to be different, so let's get the inner body there. All right. And then this warning shouldn't exist. Instead, we will want a warning. I was about to say that we want a warning that there were no values in this list, but we are guaranteed that there will be because the keys exist. So we can just get rid of that warning. And then do a for loop around this one. So we do for I guess it would be for every string vector, every string in this vector. So for const std string reference s in m.a section key. I might be in a little bit of trouble by using const, but okay, no, that seems to work fine. Now we've got every string, and we're not just accessing the first element. We get rid of front. Right? Well, we get rid of the whole thing. We just do s, right? Okay. And now this function is ready to go as well. Because once we get this working, return the correct return val, both of these will work as planned. It's just the conversion function that we need to deal with. Though until we fix it, this is not going to compile, and I'm just going to let that be for now. Take a look at how these conversion functions work and see how hard it would be to implement the other versions. First thing I'm going to do is I'm going to reorder these to match the order we have in here. So we get int and multi-int go on top. Yeah, int and multi-int go on top. And next up we have float and multi-float. And then we've got bool, multi-bool, string, and multi-string. I think that's the order we've already got. Bool, multi-bool, string, and multi-string. And then we're into the dictionaries, which is exactly what we want. Okay, so looking at int, we're provided the section and the key in the default value, which, yeah, I do have default values here. I should fix that though for these other types, because right now I've got types that don't actually match the names of the functions. And then these vectors need to be of the right type as well. I suppose we'll need a get multi-pointer. I hadn't thought about that until just this moment. And I had done a bunch of tabs and things to try and get this to be a little more friendly looking, but it's not helping anything now. I'll worry about making this look pretty later when I go to prep it for merge. Okay. And then I need to update the right-hand side. So the default values need to be the right type. Yeah, and I don't think it's worth putting a default value here. because the default value should just be null pointer. In virtually any case that you would want to serialize pointers, which is still probably a bad idea. I'm trying to think of a use case for the pointer being serialized. Like if you were using the pointer to be like an offset, and I don't know. Maybe I should just scrap pointer. I have it there for the sake of being complete. I'll leave it. And now we're in get bool, which has a default value. And get car. I guess it should have an optional default value. Yeah, that's the all the signatures corrected. Heading back to the reader, get int default val. This is another incorrect accessor check. We're checking to see if there's any of that size. Really what I should be checking is whether this key combination exists. That's the same thing I corrected in the dictionary parser, or dictionary getter. And then I get a converted value from ini string to int. So in this case, there's not actually a lot of complicated parsing going on with dictionary, or with like you would have with dictionary, because the text that is stored at mdata section key is either an integer or it's not. And if it is, you just directly convert it. So we just invoke the function up here. I think I'm going to keep this style where it returns both whether it was successful and what the value is. And basically these are like, this is just a wrapper around stoi, string to integer, somewhere. And it's wrapped around a try catch block, which I don't necessarily like. But std, s2i, when those fail, they throw an exception. Maybe I should go back to the C style or the C version of S2I, because they don't throw exceptions. Exceptions are a C++ thing. But I'm on the fence about that. Yeah. Okay. So what I'm going to do is I'm going to, because I need to do some other things, I'm going to go ahead and put some notes on what to do next. Pick up here. I actually don't need to tell myself what to do here. I just know that this whole thing needs to be really rewritten and to do for the rest. And then in get dictionary, I need to fix the other. So I'll do another pick up here, and I'll pick up here is a comment that I like to insert into code when I need to have just like a bookmark. I know that Visual Studio literally has bookmarks somewhere. I just never learned how to use it. And then I'll remember to come back. So yeah, I guess the next bit of work that needs to be done, we got quite a lot of work done here today. We got a whole new API figured out for reading. We've got, we went through the parser to allow us to use multiple section filters for filtering out sections. We resolved a couple of bugs that were left over from the first time I wrote this. And now we are at the point where we just need to do the conversion functions and implement the rest of the getters. So we need to get the conversion functions for actually converting the text into the correct format. And then we need to get the dictionary parser to invoke all of those on the correct types when we need to get the data out of something like this outside of a dictionary value. So yeah, it's quite a lot of work. If there was a library that met all my needs for INIs, I would have used it instead of having to go through all this, but there wasn't one that I could find. At least there wasn't when I originally wrote this years ago. So yeah, I guess we're gonna do more parsing work tomorrow. Yeah, all right. I'm gonna go ahead and close this out. Thanks for people who popped in and followed. Have a great night.